Hello, everyone. Hope you're all well. Welcome to the first of a series of the Cathx Ocean webinars. You're all very welcome for joining us today. So today we actually have people joining us from all over the world. So good morning to some and good afternoon to others. It's great to see such a mixture of people here today as well. All sorts of stakeholders from the industry. Perfect. So the agenda today for this webinar, we're going to aim to keep it within the hour, and then we're going to have enough time at the end for our questions and answers today. And just to give you an agenda of what's going to be happening, we'll have a quick introduction to the panelists, and then we're going to have our first speaker who's going to give you an introduction to Cathx Ocean as a company, and of course as the main topic of the day, which is CATHX FDI Seabed. And our next speaker will bring you into CATHX FDI services and what that looks like in the field. And then finally, we will have CATHX FDI and CATHX AFDI, which are our Voyage and our road to automation. And then at the very end, we'll have your questions and answers, of course. So our speakers today is including myself. I'm Catherine Bury. I'm the newest member to the team here at CATHX, and my role is Senior Business Development Representative. I've actually met a few of you joining here today. I've met you virtually already. I definitely look forward to virtually meeting some other people here in the near future. So our first speaker today is Adrian Boyle, who is our CEO. Next up, we have Richard Close, who is our COO. And last but not least, we have David O'Reilly, who is our CTO. So today we're recording the event, so it will be available for you to watch again on YouTube from this Friday, the 3rd of September. So feel free to go back over any of the information that we've gone through. And then, as I said, there'll be a Q&A session at the end. So there's a Q&A button at the bottom of your screen. So feel free to click that button and submit your questions as we're going along, and we'll try our best to get to as many of them as we can. So I'd like to pass over to our first speaker, which is Adrian Boyle, our CEO.
So yeah, I'd like to welcome everybody. I think we'll go straight into and onto the first slide. So just for those of you, I'm going to spend maybe a couple of minutes just giving a background to CATHX. I think many of you are familiar with CATHX already. Some of you are not, but effectively CATHX started in 2009. We specialize in optical imaging and machine vision, particularly for automation and for automated operations. Our manufacturing and R&D facilities are headquartered in Ireland, but we pretty much operate globally, and particularly over the last 6 years, we've operated in all parts of the world and in all ranges of the subsea sector, oil and gas, wind, defence, and to oceanographic research. In 2012, we filed a number of patents that cover some of the core technologies. I won't go into all of those now, but if you do a search for CATHX research, you can certainly find them. But the technologies that we describe today are very much described in detail in those, but our presentation today will largely focus on FDI for seabed, as distinct from FDI for structures, which will be another session possibly in about a month's time. So today we'll pretty much cover what FDI seabed means from the highest level, which I'll cover, but then down to the service today from Richie, and Dave will give a picture of what that looks like as we move towards autonomous and uncrewed operations. Our customers globally are pretty much, historically, we have a large contingent of customers in the subsea services sector. Contractors, MMT was one of our earliest customers in 2015. Deep Ocean and Kongsberg have our systems in use. To a large degree, it started off with pipeline survey, but it's become much broader than that ever since. So as a business, we provide systems and services to pretty much the broad base of subsea vehicle manufacturers, to service providers, and also to asset operators in the oil sector and the wind sector, for example. Rather than spend too much time in terms of the vehicles, this is the kind of typically what our integrations look like. So most of our systems are rated up to 6,000 meters. We have systems going online for shallower water soon. But in effect, for large vehicles, underwater AUVs, ROVs, world-class ROVs, in the past, this has largely been integrations aimed at integrating with the workflows that are used today for the subsea survey process. So the move towards uncrewed operations is largely shifting what we used to do historically, which for ROV operations where we have people on the boat, and we're able to support that activity locally, integrate with existing processing software. That transition and industry transition towards uncrewed operations is fundamentally shifting how we operate, in the sense that certainly over the last year and a half, I think everybody's conscious COVID means less people offshore. But one of the big challenges, how do you perform subsea visual survey from an uncrewed vehicle when you're many thousands of miles away? So from a CATHX perspective, much of what you'll hear today from Dave in particular in the latter half of the conversation will be around how we're planning to get there. And Richie will talk about the services today on the way to that. And I think, again, from an industry perspective, oil and gas, defense and cables, the standard industries, the other thing that's happening in the industries we serve is a fundamental shift into sustainable operations, into environmental impact assessments. Most recently, we've done work with deep sea mining companies and survey companies involved in the deep sea mining sector. And this is largely governed by the drive for electric vehicles and the demand for minerals. But one of the key aspects of these more recent developments is monitoring the environment, and particularly monitoring the impact of our operations on those environments. So from a CATHX perspective, when we talk about FDI for seabed, we're talking about it in the broadest sense. Although a lot of our historical work has been in the subsea pipeline sector, we're seeing a substantial increase in interest in monitoring environmental impacts before and after subsea operations. So when you look at the presentations today, keep in mind that while we talk about specific applications, the application base is much broader than that. And to try and put in context some of our history and where we're going, if you look back at 3 years ago, 2018, before we really got moving and performing FDI with the existing vehicle fleet, typically, if we take the case, and I'm talking about very specific cases here of a 30-day pipeline campaign, what we typically found was that it could take 30 to 60 days after that to generate the data deliverables. What FDI does in the first instance is it reduces the data acquisition time. And this is achieved by essentially increasing the ROV speed or the AUV speed. We still have, because many of the workflows have been are using the traditional techniques, still takes a considerable amount of time to generate those deliverables. But where we're moving with that is towards the automated processing of that data, so that we have, in the first instance, uncrewed operations where the data processing happens at the edge, and in the longer term, autonomous operations where, in fact, all of the processing happens on the edge and the data arrives back with the vehicle. So this kind of drives, if you like, the time to deliver the data product, which is really in the seabed environment. What are we looking for? What is the important data? And what data should we process first? And that's across the broad range of applications. So what is fast digital inspection? In maybe 2 or 3 slides, I'll give a quick overview, but it's a technique to acquire and process large areas of visual data on the seabed. F stands for fast, so we want to do that very quickly. One of the key things to remember is that when we're acquiring data quickly, we don't have the privilege of reviewing it as it comes in by eye. So we need to QC it, bring it back to shore, and perform the inspection onshore rather than offshore. So the purpose of it is to assess the asset and environmental integrity in the first instance. And what CATHX is actually providing, what FDI is it's not just about the service we offer today, but it's about providing the technologies to enable autonomous machines, such as uncrewed surface vessels, resident subsea vehicles, autonomous vehicles, to use this information and to perform real-time operations in the future. So in doing so, we reduce the cost to acquire and process information and to consume visual data so that we actually enable much greater visual coverage. And this is more to allow us to better monitor and detect changes. So when we look at the tool sets to do that, we're talking about getting the cost of acquisition and interaction with data as low as possible, so that in fact we can collect more data, visual data, more effectively and more cost efficiently. What FDI is really, in the first instance, reducing the vessel time. And remember, this is pretty much field proven across multiple contractors, multiple operators, multiple applications. We reduce the vessel time by 75%, up to 75%. The effect of this is a substantial reduction, obviously, in the CO2 consumption of that vessel. It's a reduction in the HSE risk for personnel offshore. And then from a reliability point of view, when you're trying to do that work in 1/4 of the time that it traditionally took, it's quite important that the reliability of the systems is good, so that 6 days instead of 36 days doesn't become 16 days. So Cathx, over the last 6 years, we've put multiple systems in the field in manned environments or crewed environments to facilitate, and we've constantly improved the reliability of the systems to achieve that. And that serves us pretty well as we move into the next phase, which is doing that work in uncrewed operations. The other side of it is the data quality. We typically, compared to conventional video or conventional inspections, we move the inspection onshore. We do the QC offshore. That data then allows us to look at things like automation from the context of year-on-year change detection. Richie and Dave will talk to you more about what those deliverables look like and how we're planning to do that. But the key point is data quality, image quality, large area imaging, and large area at low cost is one of the key drivers and one of the key benefits that FDI for Seabed delivers. And to kind of put some numbers on it, typically, as I talked about before, we cover a lot of different types of vehicles, autonomous vehicles, ROV and towed vehicles even. If we look at one case, but this does apply to pipeline and to seabed, we covered 900 kilometers of pipeline in 16 days with a work-class ROV. We collaborated with a contractor, a customer. And what this allows us to do is grab very high resolution, well-lit images at speeds, in the case of a work-class ROV, up to 2 knots. But when we started out, some of the fast ROVs typically operate at 4 knots and 5 knots. AUVs operate at 5 knots. We still acquire these high-resolution visual image data sets along with spatially registered laser data. And these 2 sets of data together give us the tools that we need to generate a very unique set of deliverables in a way that we can now start to interact with that data, not only to improve the current operations for survey and integrity management, but actually to bring us much faster towards uncrewed and autonomous operations in their entirety. And to kind of, just for me to close out, what we're talking about is essentially CATHX FDI. Really what we're saying is that we acquire much better data. We acquire very, very quickly. That facilitates processing of that data to get to decisions much faster. While we offer the services today, what we're really doing in parallel is building the data infrastructure, the data services to effectively future-proof this technology so that it operates with uncrewed and autonomous vessels. And our vision for AFDI is ultimately that we will facilitate the collection of large-scale visual information in the ocean so that we can actually get much more information in the first place and monitor change much better. So with that, I'm going to hand over to Richie to present on what our FDI service is today, what that looks like in a little bit more detail. And then following that, David will talk to you through particularly the technologies that we're using with a view to uncrewed and autonomous operations in the future. Thank you.
Thanks, Adrian. My name is Richard Close. I am the Chief Operations Officer for Cathx Ocean. And what I want to do today is to talk about the services that we offer currently within the Cathx Ocean company. So Cathx Ocean offers fast digital inspection to any clients who wish to use the system, especially clients who rather use their operational budgets, their OPEX budgets over their CAPEX budgets, which makes it a lower cost of entry into fast digital inspection, fast digital inspection deliverables. Every FDI solution that we develop for a client is tailored based on the client's actual data requirements, what they need at the end of the day. And it also takes into account the assets to be surveyed, the vessel and the vehicle features also. So when we put a plan together, we work very closely with our clients to understand everything that we can gather about the project at hand. The services are offered across all offshore sectors, be that oil and gas, renewables, oceanographic surveys, all depths, so we can go from 0 to 4,000 meters and locations as well. So we work on a global basis. And basically anywhere where more information is needed, we can be made available to assist in gathering that information. And wrapping around all this is a lot of hands-on support from the project kickoff right through to the project closure when we deliver our final deliverables and report. And this is made possible by a team of very experienced CATHX engineers with experience in offshore and remote support as well. So the Seabed survey equipment, essentially the scope of work, as I just mentioned there, determines what systems we choose to use. So again, like I said, depending on the vehicle you have available to you, the requirements of the survey itself, if there's a need to fly no higher than a certain altitude or at a certain speed, all these pieces of information we take into account before we make our proposals in terms of the equipment that we use. But in terms of the standard set, let's say, in this example here, we'll talk about our Pathfinder solution. These are products that we offer to our customers, but we also use them for our services too. And you can find out more information about them on our website. The Pathfinder solutions typically are used where you have a need to fly quite low to the survey area. You may have other sensors on board that need to be a little closer to the target, for example, but you still require a wide swath of seabed to be surveyed as quickly as possible. And you know, the Pathfinder and Hunter systems can give you options there in terms of a Pathfinder can get you wide swath at low altitudes, whereas a Hunter system can be used to acquire data at higher altitudes if you need a narrower swath. So we collaborate with our clients on the equipment positioning as well. So as you can see in some of our shots here, that we will work very closely during the integration phase onto the vehicle itself as to where each item of our equipment gets placed. We will also work with the client to help design any survey frames that may be needed. If there's not one there available already, we're more than happy to get involved there and to give feedback on any potential frame designs. The systems themselves as well, it's quite portable. Even the largest of our systems is 3 pellet cases, and one of those is actually our rack-mounted server system and NAS system. We also provide any IT hardware that's needed to on the vessel itself. So like I said, servers, PCs, laptops, and primary storage as well. And that primary storage solution can then also be hooked up to any vessel IT systems too. If there's this data backup solution on the vessel, we can also integrate into that as well. So then just talk a little bit more about some of our other equipment. So we have developed a new product that's currently, well, it's gone out of test now at this stage. It's traveling to the Gulf of Mexico, and it's the Cathx Vanguard system. And this is developed to mainly work with clients who have smaller vehicles or require faster deployable solutions and simpler to operate solutions as well. And I'll explain a bit more about some of those requirements in a little bit. But essentially, we have a very compact system which still will acquire the same data sets that we had before, with the added advantage that there's no calibration required. The system is a fixed unit with 2 imaging systems which can acquire images and one can acquire video. And we also have a laser emitter with a laser camera in there also. So we have a lot of sensors within a small space of less than 1 meter in length. Very easy setup and operation. We essentially have 2 external cables into the solution coming for power and comms. And then we also have a 1 or 2 cables leaving the system to our light panels as well. So it's a much simpler setup from a user perspective on the boat. You can quickly mobilize this onto a vehicle. The field applications. So like I had mentioned earlier in the last slide around the types of mission profiles, whether you're flying low and looking for a wide swath or you're flying high, narrow swath, you essentially have the same applications for this system as well. In the future, we will be looking to be able to connect multiple systems together here, but for now we're working as a single unit. But what's good about this system here is that it can be applied to standard fast digital inspection, say of a pipeline. It can also then be used in infield survey on a smaller vehicle, and it can also be used to gather data from metrology services as well. So in terms of the data that we can process, so the systems themselves are designed to acquire a range of raw data sets. So this could be UHD or HD images, UHD being 4096 by 2304 image size, or HD images. We can also acquire the laser data as well from our laser systems too, starting at a minimum of 30 Hertz. But that's just the ingredients for our final data deliverables typically. And what we can do with that and with some processed navigation data is then start to generate GIS type deliverables. So we can generate geopositioned images, and we can use world files with those. We can also create octa-rectified images as well. We can create standard point clouds that have are colored by depth or intensity. And then when we start to merge our data sets together, we start to generate additional value. And this will be in using an example of a color point cloud. And I'll talk a little bit more in detail about that shortly. So to give you some examples of the types of images that we can acquire. So this is a standard, pretty standard type of image that we can get typically when we're out on a survey, certainly in the Southern Hemisphere. But what makes this unique and what I can draw your attention to is the focus. So our images, our camera systems continually adjust focus based on range to target. And that information is fed in from external systems, but it's constantly monitoring that focus range and adjusting our lens to keep the images sharp. There's no motion blur in this image either, despite the vehicle moving. Your shark is twitching as well. They're about to bite into a fish you don't see yet further up. And that's because we have very short exposure times. And we've managed to achieve that by using our AFOS 32 lighting systems to illuminate the whole area and to allow us then to have a very short exposure time. Short exposure times means we're not getting any movement during the time the sensor is exposed. And also we have a large depth of field within our camera system. So this means that should the vehicle make any sudden increases elevation quickly or decreases it suddenly, we won't see that impacting our focus, our ability to stay in focus as well. So we have this consistent high quality image and sequence of images then that you can see here. And again, in the next example, similar again, this is of a very plain pipeline with some life around it. Again, there's a high level of detail there. We're not seeing any motion blur, and we have these evenly lit scenes. And just to talk really quickly about the evenness of the lighting, where we have any issues with light or where we have lighting that's not quite even. For example, we have a lot of lighting in the center where it gets dark towards the edges. With our post-processing services, we can then look to even out that lighting as well. So you have a consistent coloring across the entire image, and then across your sequence of images as well being acquired. And then when it comes to the laser that we acquire, so like I said, we capture at a minimum of 30 Hertz, and we can go higher. It depends on our configuration, but we can certainly go higher. We have 2048 points per line. And for positioning, we use navigation data provided, and that allows us then to geo-position the data itself. The next image here is may actually have clicked too fast. The next image here is another laser acquisition. This is colored by depth, and essentially we have used we've traversed over a sea wreck in the Black Sea here, and we have laser scanned it, and with the process navigation built out this structure here. Obviously, should we have acquired laser in parallel rows, we can obviously bring that together as well in the visualization tools. And then just, I had mentioned color point cloud. So this is an additional data deliverable that we can offer, and it was designed to address some of the issues when it comes to mosaicing large tracts of images and photos. So essentially, as you create longer and longer mosaics, any errors or deviations in the feature matching continue to, the error rate increases the further down the mosaicing pipe you go, let's say. So in order to, that by itself there, so I'll just back to this for a second. So in order to overcome that and to offer what we feel is a data set that offers more advantages, is we combine our laser and stills data. And what we do here is we take our laser data. We then, for every point on a given laser line, we then reference the image that was acquired at the same time, the co-registered image, and pick the color from the point from the image, and then we place that color within the point cloud point. And this can be viewed as an RGB view within your point cloud viewer. So what this gives you then is the precision of the laser data. So you're not having to deal with feature matching or any kind of object detection. But at the same time, then it does give you the cues that you don't realize you see from coloring of the point clouds, which is only visible within the images. So, for example, if you have any writing or markings on the structure, you're not going to see that within the point cloud structure itself, but when we color it, you see those markings. And I mentioned it earlier on, but our equipment has multiple applications. So we can travel out and inspect an export pipeline. We can take the same system and we can, in the future, look at structures, and then we can go infield and we can perform metrologies as well. So we can, with our systems right now, we have the ability to, for example, perform spool metrologies by running over the solution. This is still a fast digital inspection as well. There's no stopping, landing the vehicle, grabbing data. We are actually just traveling over the area to be measured. And from that data, then we can provide reports on elevation differences, linear measurements, and angle offsets as well. But again, as I stress, it's the same hardware that can do all these different applications. And just one important point here, but despite all the technology that I've kind of talked about and our data deliverables, a lot of this is still driven by people currently. Dave will have other ideas when he speaks shortly, but right now we have a team of very skilled engineers who can travel out and work on site, whether it's during the integration phase or the data acquisition phase, to ensure the best data is acquired. Where travel is limited, as we are right now, travel is very restricted at the moment, or impossible, or even to the point where there is no, if you have an unmanned surface vessel, there won't be a person on board. We will then be able to provide training and an entire support package. And this can include hands-on training for the on-site technicians during the integration and test, real-time support using whatever the local hours are, and this can be provided over phone, web conference, radio, other medium of communication that works for our clients. And we can also have remote access to our systems as well, providing we have a suitable connection. So this just allows us then to control the systems themselves if needs be. It's probably important to state here as well that we have a lot of automation built into our camera systems themselves. So there is no need to be constantly adjusting focus or exposure times or aperture settings on our cameras or virtually any other settings. The cameras themselves work primarily by analyzing data acquired in the previous fraction of a second and make adjustments off the back of that. So to constantly ensure we're hitting a certain window of quality in our data being acquired. So there is limited hands-on control needed there. We do offer real-time data QC applications as well within manned surveys. So this allows us to visualize both laser and image data as it's been acquired, or very, very shortly after it's been acquired, we'll have it being displayed. So in summary, and this probably sounds a little bit like what Adrian had mentioned as well, but it's very important to reiterate this. The main benefits around the services that we offer, first off, as I said, this can be funded via OpEx budgets if it's available. There's no capital expenditure here at all. We deliver across a range of areas, but again, savings in vessel time, which reduces the HSE exposure and reduce emissions of the vessel itself. We provide a range of high resolution scale data sets that, when compared to more traditional survey approaches, we feel are much higher in quality and offer greater insights and understanding as to the state of the objects under survey itself. And we also wrap that around with a 24/7 on-site or remote support or remote operation solution as well. So we ensure that there's always someone there to have the best data being acquired at all times. So that is everything from my side of things. I'd like to hand you over now to Dave O'Reilly to talk about what we're up to in the future. Thank you.
Thanks, Richie. Just to introduce myself, my name is David O'Reilly. I'm the CTO at Cathx. And what I'm going to be focusing on today is how we're taking what Adrian and Richie has already described in terms of the CATHX FDI Seabed and what we're doing to automate as much of that as possible to allow some of the benefits that we're already getting through the hardware systems that are in the field today and the services that are offered, how we get that value out of an automated system or an automated version of that. So I'll just do a quick overview of how we hope to do that, and got control of the screen here. I do. Okay, so Richie has already described in detail there what we're doing in terms of the hardware. And so a lot of the hardware has already been improved such that it's fully automated. We don't have to worry about auto exposure or auto focus. The hardware systems that we have, we've had a lot of history with them. There's been a lot of learnings from it, and we've put all of our learnings into the most recent product, the Vanguard that Richie mentioned, and that's gone into field trials just lately. What I'm going to focus on today is more on the software side. So Richie described quite a few offerings there in terms of the services that are offered by Cathx. What we are trying to do, what my team is trying to do, is take those services and encapsulate them into what we're calling microservices, that can then be used as building blocks to build out an automated workflow that can be run ideally at the edge when the data is being acquired, so in real time and keeping up with the acquisition of the data. And what that allows us to do is to collect data from the scene much earlier than what we traditionally have today, where the data, the acquired data, is brought back to shore and processed and then goes through a visualization and inspection process. If we can extract information from the scene at the time of acquisition, that allows us to do a couple of things. First one is to raise events or alerts on the information that we've extracted. And that information will also allow us to prioritize some of the processing that may be most valuable to a user at the other end that's doing the actual inspection of the scene. So if we move on to the next slide here. So how are we going to do this? So the first, there's two main software products that are being offered here to get to that stage. The first one, which I'm just going to briefly talk about as an overview here, and I'll go into detail on the other one, but the first one is CX Observer. This is CATHX offering for the visualization and inspection stage of the process. And I'm kind of starting at the other end. I'll move towards the hardware now as we go through this. But what this application will allow you to do is to navigate the 3D scene through a point cloud, for example, and be able to focus in on areas that are of interest and pull up the 2D images, the high resolution 2D images, just by clicking on the 3D point cloud. So if there's a field joint on a pipe and you want to see the images from that area, you click on the points that are on that are represented in that field joint, and the 2D images of that area will come up. So that allows you to look at all the detail that's available from both the raw data collected and also the process data. It also allows us to visualize other data from other sensors in the same scene if they're positioned in the same way. So that's really what CX Observer does. I just wanted to outline what it does here now because it's important at a later stage of how we are going to improve the automation of the data processing. So if we move on to the next slide here. Oops, sorry. So CX Insights is the bit that I want to talk about the most today. So CX Insights is a framework that is going to take those microservices that we've developed and automate the execution of them. So the microservices themselves are being developed using cross-platform methodologies, so they're suitable for being run at the edge. For example, where the data is being acquired by a camera, for example. But it can also be used at the other end where the data is being visualized. And there's a couple of different benefits to being able to do that at both ends, and the benefits are specific to either side. So I'll get into that in a bit more detail in the next slide. But essentially, CX Insights itself is just the engine for automating those microservices. And what we will do as we move forward through this development is add to the microservices that are available. The microservices can be collected together into application-specific libraries. So we can take microservices that may be most useful for, in this example today, we'll use pipeline inspection. And they can be configured into they can be put into a pre-configured workflow so as that we extract the information from the scene as quickly as possible and make decisions on it as quickly as possible. The microservices, because they're cross-platform, will also be available for use in CX Observer. Now, what that does is it will allow us to process just the data we need at the time we're visualizing and inspecting. Now, that not only allows us to reduce the time to visualizing the data, but also it reduces the amount of data volume that we need to store. Because obviously, if we can generate a 3D point cloud on the fly of an area of interest, we don't need to store it all the time. So there's a bit of a saving there. So what I wanted to do here was just use an example, and this particular example is a pipeline inspection. So on the left-hand side, we have CX Insights, the sort of pink box there, and on the right-hand side, we've got the CX Observer, which is the visualization and inspection. The basic services that are in CX Insights would be the acquisition of the data, and then what we do then is we pass that information or that acquired data through to the application-specific microservices. And as you can see here in the gray box, that kind of joins between CX Insights and CX Observer. we have things like circularity tracker, free span detection, which is the one we're going to focus on today. But we also have the ability to identify that, you know, there is an anomaly in the laser profile, and that we might want to pull in an image, a white light image, to inspect it further. But for the purposes of today, we'll just focus on the free span detection. But what I wanted to highlight in this slide was that the CX Insights and CX Observer, they are available in for all applications, and it's standard. They're standard microservices available for all applications. What we do if we move to a different application, and I'm just going to pick another one here, which is mine detection, we'll simply take out the seabed specific microservices and we'll put in mine detection microservices. And in the same way, we'll use the laser to identify where there might be areas of interest, and we'll pull in images to do further inspection on those. And what that does is allows us to focus our attention at the visualization and inspection stage. So this is where we're at today. We have traditional acquisition of data, we pre-process it, and we produce data products. And that's for some people that are familiar with our products, they will recognize some of the data products that we have that Richie mentioned earlier, like 3D point clouds and 2D rectified images. Where we're moving to right now is the introduction of CX Observer, and that allows us to do visualization and inspection on that data, but also to tag the data. And in the process of tagging that data, what it allows us to do is to manually classify the data into data sets that we can then use for training an automated classifier. And that's where we're going to be moving to in future developments. So what that'll allow us to do is, in an offline process, using CX Observer, tag the data, generate data sets for training, generate an automated classifier, which we can then plug into CX Insights as a new microservice and do it at the edge at the time of data acquisition. And that allows us to take a process that we might require a human to do the inspection and do the tagging. We will move it as an automated microservice into the automated workflow in CX Insights on the vessel that's acquiring the data. So moving on, I said we just focus on the free span estimation here now for this particular slide deck. This is just an example of where we use a couple of microservices to do this free span detection. So the first microservice we use is what we call pipe tracker. What it does is it identifies in every laser profile. So as Richie mentioned earlier, we capture laser at 30 plus hertz. What this is doing is in each of those laser profiles, it identifies where the pipe is in the laser profile and where the seabed is. And by doing that segmentation between pipeline and seabed, it allows us to dive further into that data and start to understand it a bit better. So now we have an awareness of the scene that we're looking at. And in this particular application, free span, what it allows us to do is calculate that separation of the bottom of the pipe from where the seabed is. And it allows us to raise alerts on where we have identified free span. So that's the separation of the pipeline from the seabed. So what does that do for us? That first of all allows us to, in real time, as the data is being collected, this particular application is for an AUV, but these screenshots here show that where it could be used for an ROV, maybe in a pipeline application. It allows the user to monitor that separation of pipe and seabed and raise alerts at the time that the data is being collected. So there's no need for the storage of the raw data, processing and then visualizing it afterwards. So it can all be done in real time. So just there's a few more microservices that we've been working on, and these also will be available within CX Insights or available to the services that Richie was talking about. One of which here is orthophotos. So this is a series of orthophotos that have been titled. It's where we take the images that we've acquired and the laser that's been acquired as well. So as Richie said earlier, they're both co-registered spatially. So in a similar way to how we color the point clouds, what this is doing is actually positioning pixels from the image and then projecting them down onto a 2D plane. And what it does is it gives that more realistic representation of the objects that are in the scene. And another one here, which is very similar to the ortho photos actually, but what it does is it retains that 3D information, and you get a 3D mesh as a result. So moving on then, just to recap where we see the benefits of this are. So by enabling the automation of data extraction from the scene, what that does is it allows us to, or allows the customer to make decisions faster, much earlier in the data processing, acquisition and processing workflow. It allows us to highlight areas of interest such that we no longer need to process all of the data straight away. It's still available to be processed if that's what is required. But what we can do is we can prioritize the processing of the data in the areas of interest. For example, in this case, where there may have been free spans. So, you know, for a particular pipeline survey, there might only be 0.5 to 1% of it might be free span areas. What we'll do is we'll just process that data first and make it available for visualization and inspection. The remainder of the data can be processed as well if necessary. But you know, that early delivery of information is what we're focusing on here. Because we're using laser, the reliance on some of the traditional photogrammetry methods, which would use features in the scene or features in the images to do feature matching and then position the pixels in the image. We don't need that. We're using laser to position the pixels, or we're using the pixels to color the laser. That depends on the output that you're looking for. And that means that, you know, the process that we use to generate these data deliverables is much quicker and is much more robust and much more reliable in its output generation, and because we're not relying on the content of the scene to be able to do some of this stuff. So that's where I have. So that's our developments that we're working on at the moment. And where we see this going into the future beyond that is full autonomous data acquisition and data processing on the vehicle, with transmission of the priority data back to a base. And this is just an example here of how we see it all working together. So we have CX Insights working on the vehicle, either the submersible vehicle or on the surface vehicle. And you know, obviously the bandwidth back to the onshore facility can be quite limited. So because we're processing and extracting the areas of interest at the edge, we can minimize the amount of data that's passed back to shore, and therefore be able to do a lot more in real time remotely. So I think that's the last slide that I have. I think, Adrian, did you want to take this one?
So just to kind of round off the session starting from our presentation point of view, I hope everybody's a little bit clearer on what FDI is. As I mentioned, we're talking particularly about the seabed here and downward facing systems. What we're aiming to do and where Cathx is going with this is FDI is essentially a service that we offer today, but we're keeping and investing heavily into real-time automation so that we can not just acquire data, but process data as it's acquired. And that means processing it on the underwater vehicle and processing it on the uncrewed vehicle. So really where we're trying to get to is get the cost of acquisition so low that we can actually enable the collection of much larger amounts of data. And this is becoming particularly important for us when we look at environmental monitoring, especially in the deep sea mining zones, in wind farms, and certainly in the food chain. So we have a lot of experience in terms of data collection with these areas, but the sustainability aspect of it is, it requires that we actually drop the cost of imaging and interaction with image data substantially. And that's what this is all about. So for us, it's really about monitoring and detecting changes by collecting data much more cost effectively and much more frequently. And that's what I hope that everybody's got that out of it. We've covered very much seabed, but the other side of what we do is FDI for structural surveys. And we have systems going out, as Richie mentioned, in the Gulf of Mexico in the coming weeks, in fact, to do this. So FDI for structural is very much about the same thing. It's about reducing the cost, reducing the time, moving people from the offshore environment to the onshore environment. And I think that does set us up pretty nicely to answer. We have 3 questions in, and we can maybe pick those off one at a time and see who can answer them.
I'll just take the couple of questions we have coming in to end off the session. So the first question we have is, when do you think the Vanguard will be available to purchase?
So we, as you said, the Vanguard is a new product. We're going out to sea with it in the next few weeks, and not just to qualify the system, but actually the entire service. So both for the downward and forward facing varieties of it, we're building a number of units this year for shipment in Q1. So I think the answer is it's available now. So if anybody's interested, it's not just the system, it's the entire service, the software, the solution, if you like, from end to end. And that can be for one job, it can be for any duration, it can be for short term, or it can be for long term. And we're talking to a number of clients. We're building, at the moment, the plan is to build 10 of them for Q1. And we would see 2 going at a time. It's a relatively new product. We'll have a unit and a spare going out anywhere. And I think from that, if anybody's particularly interested in buying, well, in terms of how we sell it, we'll talk a little bit about that to anybody who's interested, because as Richie mentioned, this isn't just about a CapEx purchase. To some extent, we've tried to respond to our clients in terms of how we offer that service so that it's over a longer time period. So we can talk about that, and that becomes particularly important, I think, as we look at how autonomous processing and uncrewed operations are going to occur. So for sure, it's available. We'll certainly be shipping them for services between now and the year end. And certainly, if anybody's interested, I think we'd be in shape to ship units in the first quarter. Hopefully that answers that question.
Perfect, thanks, Adrian. The next question we have is, when you get to the autonomous era, will the inspection happen in real time on shore? And I think I'll hand it over to Dave.
Yeah, that's a really good question. So I think, as I highlighted there in the last slide, our vision is to be able to use the autonomous eventing to identify the areas of interest and the areas that will be of most interest, in particular to the inspector that might be on shore. That will allow us to kind of bracket off the data that describes the scene of that area of interest, and then transmit it back to shore. So I think the first stage is building out those autonomous event classifiers, and the next stage absolutely will be transmitting the data needed for the inspection.
Perfect, thanks, Mel, Dave. Another interesting question that's come through: color point cloud is an interesting approach. In the color point cloud, do you think it would be possible to segment the seabed and identify different materials?
So yes, absolutely, but it's not necessarily the best way of doing it. What we are doing at the moment is we're using just the raw laser, the profile in the laser, to identify anomalies, anomalies in the scene, right? So first thing we do in the case of pipeline inspections is we segment pipeline and seabed, so that we know which parts of the laser profile is attributed to which area. And then we look for anomalies in those profiles. So in the simple case here, we have a pipeline. It should be circular. And if we receive a laser profile where it's no longer circular momentarily, it's either an object that's on the pipe or maybe there's a dent in the pipe, but there's an anomaly there that we can't quite classify with a single laser profile. So what we'll do, we'll actually pull in an image of that same area, because we have control of both the laser and the images, and we'll use the image, which is generally of a wider area, that will and that will allow us to identify and classify objects that are in the scene. So that kind of goes back to what I was saying earlier about, by manually visualizing and inspecting the data, allows us to build up these data sets, which we can use to train automated classifiers. But more often than not, it'll be using machine learning to generate those classifiers, which will then get plugged back in to the automated workflow, so as that it's done in an automated fashion, and those areas of interest then are highlighted the next time we go out to do a survey.
Perfect. Thanks again, Dave. And the very last question we have, can I use my organization's own machine learning technology with this framework?
So today, CX Insights is being developed primarily with just microservices that Cathx are developing. But the framework that we're building out is being built out with the intention that we'll be able to plug in third-party microservices. So obviously there will be interface rules around how a third-party microservice might get plugged into CX Insights, and obviously we need to look at the hardware capabilities, and some microservices will be more performance hungry than others. But absolutely, it's the way it is being designed at an architecture level is to allow for third-party microservices to be plugged in.
Perfect. And I think that's the last of our questions. So thanks everyone for sending them in. Oh, actually, we have another question come in. Sorry. Do you anticipate 100% inspection coverage for structural FDI, i.e. how will the likes of restricted access be captured, and can this be captured in third-party inspection databases?
Yeah, I think, Richie, I think that definitely will be answered in our next session. But I think, Richie, do you want to have we've talked about this recently. Do you want to have kind of given a bit of insight on it?
Yeah, just briefly, 100% coverage is an interesting one. It depends on what your definition of coverage is, and we can go from there. Very possibly you will have a situation on a given structure where you have limitations on where the vehicle can be positioned, which will restrict the ability to acquire the data that you need. Now, that problem probably occurs right now on certain structures with traditional inspection surveys as well. But what we need to be doing here in those situations for fast digital inspection is getting a clear understanding during the planning phase as to where those restrictions are and what we can do to work around them. And also just take into account that potentially, for the very close in data that you want to acquire, you may not be able to access, you may not be able to acquire it, but we could be able to acquire data from a further out, let's say, from a safer distance. So it is one that is a challenge for sure. Yeah, that if you have limited access, you're also going to be limited in your full coverage.
Perfect. Thanks for that, Richie. So I think that's the end of our Q&A session. As mentioned by Adrian, again, we do have another webinar coming up in the next couple of weeks on FDI structural. So keep an eye out on our LinkedIn page and keep an eye out on our website as well for the date for that particular webinar. And if you want to if you've any questions or you want to get in touch with us, please feel free to reach out to us at my email address. I think it's on the next slide. Yep, that's me, Catherine. That's my email address, or you can contact directly our sales team as well if you have any questions. And like I said, this webinar will be up on YouTube this Friday if you want to look back over any of the slides that we've put up today. And thanks, Emil, for joining us, and thanks, Emil, for all your questions. And we hope to see you and speak to you soon.
Thank you, everyone.